In this video, we'll continue studying how to solve trigonometric equations. In this particular example, we want to find all solutions for this trig equation for theta values between 0 and 2 pi. In step number 1, we want to first isolate our sine theta. To do so, add a negative 1 to both sides, add just a 1 to both sides, and we'll get a 2 sine squared theta is equal to 1. Now divide both sides by 2. We'll get a sine squared theta is equal to 1/2. Now take the square root of both sides, and we're left with a sine theta is equal to a plus or minus square root of 1 divided by 2. Simplifying this, we get that this is equal to a plus or minus 1 divided by the square root of 2, which is equal to plus or minus square root of 2 divided by 2. Now in step 2, we want to find a particular solution to sine theta is equal to plus or minus the square root of 2 divided by 2. We'll break this part up into two separate problems. We'll first look at this equation and find the solutions between 0 and 2 pi, and then we'll look at this equation and find the solutions between 0 and 2 pi. First, let's go ahead and just draw a picture of our graph. We know that sine theta between the values of 0 and 2 pi looks something like this, which means for this first equation over here, we should have two solutions. And also, for this equation over here, we should also have two more solutions. Let's go ahead and look at equation A real fast. Here we're looking for all theta values such that sine theta is equal to square root of 2 divided by 2. That means that we want our sine theta to be positive, and sine theta is positive in only two quadrants, in quadrant 1 and also in quadrant 2. We'll first start by drawing our right triangle in quad 1 with angle theta, who has opposite side of length square root of 2 and hypotenuse 2. This gives us that the remaining side also has to have length square root of 2, which tells us that theta is going to be equal to pi divided by 4. In quadrant 2, we'll have a right triangle, again, whose reference angle theta bar is equal to theta. Again, this forms a right triangle with opposite side of length 2, hypotenuse 2, and adjacent side of length square root of 2 again. Then the angle theta, we'll call it theta 1 here, will also be a solution. Theta 1 is again found by taking pi and subtracting our reference angle, theta bar, which means that this is going to be equal to this is going to be a pi minus pi divided by 4, which is equal to 3 pi divided by 4. Therefore, the solutions to part A are going to be given by pi divided by 4 and 3 pi divided by 4. Now let's go ahead and look at part B. Part B, we wanted to find the solutions of sine theta is equal to a negative square root of 2 divided by 2. Again, we can just go ahead and draw our right triangles. We know that sine theta is only negative in quadrant 3 and quadrant 4. And we can form right triangles who have opposite side length square root of 2 and hypotenuse 2. And again, the opposite side has a negative sign in it. This again tells us that the adjacent side for each of these triangles are given by the square root of 2. And so the angle between our hypotenuse and our x-axis is again pi divided by 4. So if we call this angle theta 1, and we'll call this angle here theta 2, then to find theta 1, we set this equal to pi plus our reference angle, which is pi divided by 4, and to find theta 2, this is going to be equal to a 2 pi minus pi divided by 4. The top one simplifies to be a 5 pi divided by 4, and the bottom one simplifies to be a 7 pi divided by 4. Let's go ahead and summarize what we just found. The solutions to the equation 2 sine squared theta minus 1 is equal to 0 for theta between 0 and 2 pi is given by the following four angles. Either we have theta is equal to a pi divided by 4, or a 3 pi divided by 4. or we have theta is going to be a 5 pi divided by 4 and a 7 pi divided by 4. And these are all possible solutions in between 0 and 2 pi. Let's look at one more example in this video. And in this example, we want to identify all solutions of the trig equation 2 times tan x plus 3 is equal to a 5 plus tan x. The first step is we want to isolate our tan x's on one side. So multiply out our 2 on the left-hand side and we'll get a 2 tan x plus 6 is equal to a 5 plus tan x. Subtract the tan x from both sides and subtract the 6 from both sides. This gives us tan x is equal to a negative 1. Now we want to find a particular solution to this equation here. Excuse me, not 0 to 2 pi, but actually 0 to pi. And the reason why, again, is because the period of tan is pi. Let's sketch a graph of our tan x. The graph of our tan x roughly looks something like this on our given interval between 0 and 2 pi, and this tells us that we should have one solution here. Now, since we have one solution, we can go ahead and construct this. And again, we're only looking at this upper half over here, since we're restricting our angle between 0 and pi. And tan is positive in the first quadrant, which means our triangle should be in the second quadrant. This triangle has opposite side length 1 and adjacent side length negative 1. This is a special right triangle, where this is our theta here, our reference angle theta bar. This tells us that our theta bar is going to be equal to a pi divided by 4. Then our theta is going to be equal to a 3 pi divided by 4. This is a particular solution, so to find all possible solutions, then this is going to be given by theta is equal to a 3 pi divided by 4 plus pi times k, since tan has a period of pi. And this is our final answer.